introduce methods and creating methods and using your own methods in Java. Again, they're called methods because they belong to a class. For now, all of our methods are going to be public static, so you just need to put that at the beginning when you declare a method. We'll get into non-static methods and private methods and things like that later. Otherwise, when you do have a public static method, you invoke it by naming the class's name, right? And in Java, all classes are upper camel cased. So in this case, capital M, math, and capital D, demo, right? And then you invoke the function that you want to invoke by using the dot operator. So math.square root, demo.add1. That's going to be very familiar to everybody from both programming languages because that's exactly how you do it in Python, math.square root. And that's exactly how you use structures in C, the dot operator, the direct component selection operator. The return type has to be specified. You can have a void function that returns nothing, but if you have a function that returns an integer or a function that returns a double, or like we did, a function that returns an entire list, right? Then you need to specify the return type. And you need a valid return statement. If you've got a void function, that return statement is optional, but you should put it in as return and then just a semicolon. Return what? Return nothing, because nothing appears between the return statement and the semicolon there. All non-trivial methods need documentation, and documentation should be JavaDoc style documentation here. Remember that main is a trivial function. Everybody knows what main does. That's the main entry point. When we get into actual classes, then we'll start talking about what are trivial functions, what are non-trivial functions. Basically, any function that you can auto-generate is a trivial function, right? Getters, setters, constructors, etc. So this was great and it worked. What I want to do now is I want to draw your attention to one thing. This is already all in the notes, so I'm going to go ahead and get rid of it. Let's go ahead and create another function here that doesn't just add one, it just adds one to one variable, right? In other words, instead of taking a list of numbers and adding one to each one and then returning a list, let's just go ahead and add one to a single number. Public static void, all right? We'll try this at first. Add one, add one. And instead of taking an entire list of integers, we're going to take one single integer. And I'm just simply going to add one to it, plus plus. And that's it. That's all it does. Now, this is a stupid function. You would never actually write it. For the most part, these are stupid functions too. Why would you ever want to write them? But let's go ahead and see if this actually works. So let me go ahead and create another variable down here called y. And I'm going to try to call my function add1 on x. And then let's go ahead and system.out.println y. Right. Remember that we are online. If you have any questions, go ahead and post to the YouTube live stream. Otherwise, let's go ahead and try it out. Not one. Let's go ahead and add one to, let's go ahead and make this into 10, and then add one to y, and then we'll print it out. There we go. All right, so predict. What is this going to print out? Well, let's make sure that it actually works beforehand, too. It's going to print out 10 on line 55 here. Then we try to call this function add1 that adds 1 to x, x++. Right? It will add 1 to x. Right? That is not a problem. In fact, I'll prove it to you. Once we're in the function, I'll go ahead and print out x before we increment, before we increment and after we increment. Right? So let's go ahead and run this. It's going to print out 10 here. We receive 10 and we print out 10. We increment it, so it should be 11, and we print out 11. So my prediction here is 10, 10, 11 so far. But what about this last one right here? What's it going to print out? Let's find out. 10, y. Right? This tells you that functions and methods in Java are passed by value. Right? The value of y and x, it should be abundantly clear that these are different variables because I gave them explicit different names. Down here, I'm not doing anything with y. I'm passing the value of y stored in y at this point to this function right here. Right? That's what's known as pass by value. Pass by reference would be the opposite. Those coming from a C background will know that you can do this using pointers. We do not have pointers in Java, right? We do not have memory management in Java. Passing by reference is explicitly is impossible. By the way, this is the same behavior in Python. It's all single variables are passed by value, right? You would not be able to successfully pass this by reference and increment it, right? So that is a refresher on pass by value, pass by reference. But now let's go back to our original function that we wrote up here last time, where it takes a list of integers, numbers, and it pulls out that number, increments it, and then sets it. This worked last time. Why? What does that tell you about passing a list? Is it passed by reference or it passed by value? If I can make changes to your original list, it is passed by reference. So let's make those observations here. Right? Single variables, right? In Java, single variables are passed by value, just like they are in both languages. However, objects or mutable lists, sets, etc., are passed by reference. And so you can make changes to it. In C, if we wanted to prevent changes from being made, we would put a const keyword in front of it. There is no const. There is a const reserved word in Java, but it doesn't do anything. There is no way for you to prevent somebody from making changes to your list unless you have an immutable list to begin with. Okay, and we're not going to get into that just yet. All right, or maybe at all. So there's my first couple of observations. My second observation is, remember when I created the add one copy last time? I had to name it something different. Ooh, oh wait, I got rid of it, sorry. So let's restore that. Public static void add one to int x and then x plus plus. It compiles. I have two functions with the same name, right? Can you do that in C? Nope. Can you do that in Python? Nope, right? This is something new. This is something that's a little bit more fundamentally object-oriented. It is called function overloading, right? That you can have two functions or more functions with the same name as long as the parameters are different. This one takes a list of integers. This one takes a single integer. So down here, when I actually call that function, add 1 to y, right? Int y is equal to 10, right? 10, 1, fine, just like that, right? How does the compiler know to disambiguate those things, right? It's saying, okay, add 1, I've got two functions named add 1. You are giving me an integer. Oh, you must have meant this one right here, because you did not give me a list of numbers, right? So by utilizing function overloading, we can have functions that are named the same thing, but as long as they're different in their parameters. This is built into the language as well, math.abs. Right? So those coming from a C background, do you remember we had like 4, 5, 6 different absolute value functions? Abs, fabs, labs, lalabs, etc. One for each variable type. An integer, a double, a float, a long, etc., right? Int y is equal to 10. There we go. So if I opened up the math library over here, I would see that I have an absolute value function that takes an integer. I would also see that I have an where's the other ones? Abs. There we go. Come on. Find abs. Oh, no. Somewhere in here. There's abs exact. There's abs. There's another abs that takes a long. There's another abs down here somewhere that takes a float, right? Because we have function overloading in Java, we can have multiple functions with the same name as long as they're different in the types, in their parameter types, right? We'll revisit this when we come back to object-oriented programming, okay? But otherwise, my other observation here is that, Java supports function overloading. You can define multiple functions with, or methods with the same name as long as their parameters are different. One last observation I want to do here before we move on to file I/O is not going to require any of these functions, so let's go ahead and get rid of all of them. Right? I'm going to go ahead and create a new list here. List of, let's say, integers. Just keep it simple. And I'm going to call it A. And I'm going to create I'm going to ask actually arrays.asList here. It's just going to create a bunch of, or a list for me with some random variables in here. There we go. 5, 7, 3, 4, 8, 4. Okay? Now I'm going to create another list here. Integer b is equal to a. How many lists actually exist in this code at this point right now? 1, right? This is known as a shallow copy. A shallow copy. Right? In other words, I've got a list A. A is referring to this list over here. On line 17, when I create a new list, all I'm doing is creating a reference. And then I'm saying, also refer over there to A. There's only one list in here, and I'll prove it. What I'll do is I'll say that b.append, 42. Right? I'm going to add 42 to it, and I'm going to I'm going to print out both of these, system.out.println A and B. Not append, add, sorry. I need to get my head out of Python too, right? Append is going to be Python's way of doing that. Add is your way of adding it to a list in Java. And oops, I need to print B instead, okay? So I've got A and B here. If they were two different lists, changing B would not affect A. But they're not two different lists. They're the same list. So let me go ahead and print this out and show you. Oops. It should. Maybe I didn't save it. There we go. Oh, unsupported. Okay, fine. Arrays.addList. Whoa. Abstract list. Okay. Let's go ahead and go with new array list. And explicitly just pass it in like this. Hopefully this works now. Come on. There we go. All right, I don't know why it was having a problem before. I'll have to investigate that. But in any case, did I add 42 to just one list? Nope, I added it to both. Why? Because they're the same list. These are references, right? I'm using my fingers here because I'm pointing. A reference is a pointer. And I am pointing to the same list here. That's a shallow copy. Alternatively, what I want is a deep copy. A deep copy is a completely different copy, right? That I'm going to take 5, 7, 3, 4, 8, 4, and what I'm going to do is I'm going to copy all those elements, and I'm going to put this over here into this brand new list, and I'm going to have two separate lists, so that when I change one, I will not affect the other, okay? How do I do that? Well, there's a lot of convenience functions here called copy constructors. Integer, oops, I'll just go like this. Yeah, list of integer, I'll go with C. And I'll go a new array list. And what I'm going to do is I want to copy, say, B, right? And so what I'm going to do is I'm going to put that inside parentheses. That's going to be a copy constructor. It's going to go through the elements in B, and it's going to copy each one over into this brand new list C. Right? And when I print both, and then I'm going to make a change to C, C.add 101. Right? Now, if these are different lists, completely different lists, then changes to one will not affect the other. When I print I'm going to go ahead and get rid of this so that we don't see it anymore. Now it's going to be 5, 7, 3, 4, 8, 4, 42 on both of those lists, but I'm only going to be adding 101 to C. And you can see that they're completely different lists now. This is what's known as a deep copy. In C, you would have to roll your own. You would have to create your own deep copy function, or you would have to do a memcpy or something like that. You'd have to call malloc, you'd have to manually copy things over, or you'd have to call malloc and then use memcpy to copy things over. In Python, what would you do? There's this library called deep copy. Right? And you'd bring that in, and then you would say, deep copy, I want a copy of this, this list or this set over there or something like that. Or I believe that it also has constructors as well, right? If you have a list, or let's just call it A, is equal to 1, 2, 3, 4, right? And you want a brand new list in Python, what could you do? B is equal to list of A, something like that. So this that I just presented up here of this copy constructor is basically the same thing as calling a list and then invoking this. I believe that that's also a deep copy. Right? So deep copies are a concept in every programming language, right? Except for Lisp. All right, so Java. Going to make sure that you have all that in there. Okay? All right, file I/O. File processing is no different than input and output processing. Why? Because in most computer systems, especially Unix-based computer systems, everything is a file. A directory is a file. A file is a file, right? A socket that you use to communicate from one computer to another computer over a network, that's a file. To send data from one computer to another computer, you write to a socket, you write to a file, and then it gets sent on. To receive data from that computer, you read from that socket, you read from that file. When you type, that's the standard input. That's a file. When you read this output over here in your console, that's a file. That's the standard output. The standard output is a file, right? So how do we do file I/O in Java? There are dozens of ways of doing this. I'm going to show you the easiest way, both the easiest ways. So file output, right? The easiest way is to create what's called a print writer. Print writer, PW, is equal to new print writer, print writer. But you've got to write something. What am I going to write to? To do that, what I need to do is create a file. File F is equal to new file. And I'll go ahead and just say that it's in, usually what you do in an Eclipse project, because everything is relative to the root of the Eclipse project. If I just go ahead and write a file, it's going to appear right here at the top of my project, and I don't want that, because I've got a source folder and I've got a whole bunch of other things. So what I'm going to do is I'm going to initially create a folder here for all my data files. Right? I'm just going to call it data. Call it whatever you want. All of my plain text output files and plain text input files, whatever, are now going to be in this data file, or in this data directory. So I'm going to go ahead and create a new file in that data directory called foo.txt. All right. Now I do need to bring this in. This is going to be an important file, a java.io. So what does that tell you? That it's in the input-output library, right? The print writer is also in the input-output library. So I'm going to bring those two things in. And I'm going to be reading, print writer is going to be reading, output, so it's going to be writing to that file. Don't worry about that, the compiler error. We'll come back to that in a moment, okay? Do you see a file like that in the data folder yet, already? No, because I haven't run the program yet. It's simply going to create this file, then it's going to start writing to it whatever you want. How do you actually write to that file? pw.println, hello, how are you, right? Println, what do you think it's going to do at the end of that line? It's going to print an end line character. pw.print. This is a way to print without an end line character. pw.print. See? Right, there we go. And I'm going to put my own end line character in there. Is this starting to look familiar? Println and print. Where have we used those before? System.out. What did I say that system.out was? A file, right? This is exactly the same. If you've got variables, say pw.printf, right? You can go ahead and format those variables. %d, %s, %f, right? And I'll go ahead and print out 10, hello, and 3.1, oh, actually math. Let's bring in the math library and do some more stuff with it. There is a pi defined in the math library. Use it if you need it, right? Do not roll your own pi because it will be less accurate, right? All right, that's how you can output to a file. Now, once you are done processing that file, outputting to the file, what do you do with it? You open it up. What do you need to do to make sure that everything's good? You need to close it. pw.close. We're not actually closing the file itself, f.close, because in Java, a file is not actually the file handle. It's not actually the actual file. It's just a reference to this thing on the file system. Print writer is what actually needs to be closed. Now, back to this compiler error here. This is something that we're going to talk about right after file IO. I'm going to have to surround this with a try catch. Right? That was just auto-generated code there. Let me go ahead and move all of this code up to here. I'm going to do all my file processing within that try block. If you covered exceptions in Python, this will look familiar. You're about to try something dangerous, right? Something that could go wrong. What could go wrong with file output? Do I have permissions to just write to any old file that I want? Do I have permissions to say write to an Etsy password file? Should you have permissions to corrupt the password file on the system? No. So if you do not have permission to do this, something will go wrong. That something is an exception. File not found exception or permission denied exception or something like that. In which case you can handle that error, right? Something went wrong. We tried to do some dangerous code. Something went wrong. An exception was thrown. We caught that exception right here, and then we dealt with it. We handled that exception. That's exception handling. That's something that we'll talk about here in a moment. But otherwise, I was not able to even compile without surrounding this with a try catch. I let Eclipse generate the code for me. There are better ways of dealing with this. We'll come back to that in a moment. For now, though, let's go ahead, and I do not want to corrupt my password file. So what did I say? Dated/foo.txt. All right. Let's go ahead and run this for the first time now. All right. Didn't print anything to the console. Why? Because I wasn't using system.out. I was using that print writer that's going to be printing to an actual file. Now, did you see any changes over here? No. Unfortunately, sometimes it gets hiccupy and sick. So what you need to do is you need to kick it in the butt by saying refresh my project. Right? And you'll see that the file was there the whole time. It's just that the file explorer over here was not cognizant of it. It was not aware of it until I kicked it and said, please check. There's a file there. It should be there. And I can see it now. I'm going to go ahead and open it up. Hello, how are you? This is a way to print without an endline character. See? There's no endline character. And then finally, printf right here. Right? So everything that you know about system.out, cut, paste that knowledge. All you need to do is create a print writer for this. Okay? That's file output. What about file input? Now to do that, I want a different file. I don't want to create that file. Let's go ahead and create another file over here called, I don't know, bar.txt. Right? And let's go ahead and put some stuff in it. Hello, how are you? Some blank lines. Right? A number 23. There we go. So that's just a file, whatever. I'm just putting a bunch of stuff in here because I want to read that file. My first attempt here is going to be read line by line. Okay? Now, file input is a little bit different because what I need to do is I need to read from the file. Now, from your labs, when we ran a program, I think it was the birthday program, I don't remember what it was, but you were prompted for input, right? And then you mashed the keyboard, and you saw that it was a bunch of green over here, right? If you're actually able to type. How did it read in that from the standard input? How did it read stuff in? Do you remember that class that was surrounded by? No? It was a scanner. Oops, sorry. Scanner. A scanner is going to scan the input. That sounds familiar too for those from a C background. How do you read input from a formatted, like the standard input? There's printf, and then what's the opposite? Scanf. What are we scanning? We're scanning the input. For those coming from a Python background that covered file I/O, this is going to be very similar in that I think that the usual way of doing this in Python is that you open up the file and then you just need to read line, read line, read line, read line. That's what we're going to do here. But we're going to be using a scanner to do it. S is equal to new scanner. Now what are we going to be scanning? Well, we need a file to do that. File, and I've already used F here, so I'm going to in file is what I'll call it. A new file, and it's going to be that data slash foo.bar.txt. There. Right. I don't want to read and write from the same file here. Right. And I'm going to have an in file. There we go. Now, this is also going to be needed to be surrounded by a try-catch statement. Why? For the same reason. That file may not exist. Over here, when we output to a file, it automatically created that file for me because it was output. But input, if you're trying to read from a file that doesn't exist, right, say Baz instead, right, then what's going to happen here? File not found. It's going to throw this exception. You can catch it down here, and then you can decide what to do with it, how to handle that, right? Let me go ahead and go with bar, though. Right? I'll show you how it fails here in a second. Now, once we've got that scanner, we can read line by line by line, right? We could say, let's go ahead and read the first line. String line is equal to s.next line. Now, before I do that, you'll note it here, if I just go dot and go next, there's a lot of options here. There's next, you can get the next string. The default is delimited by white space. So it would get that first word in the first line. Otherwise, you can get the next byte or the next Boolean or the next int, the next float, the next double, whatever you want. If you have a highly formatted file that you are only expecting numbers or something like that, you can go next integer, next double, next whatever you're wanting. I'm going to go ahead and just go with next line. I want you to get the entire line, whatever might be in it, and put it into this string right here. Right? Now, let's go ahead and print that out. System.out.println line. Right? Let's go ahead and get the next line. Right? Line. I don't redeclare this. Let's get the next line. Line. I'm just going to cut and paste, cut and paste, cut and paste. Right? Let's go ahead and run this. And we'll see that we're going to get those first 4 lines that I put in that file. Remember that they were indeed, hello, how are you? Right? Now, is this the way to go about doing it? Just keep cutting and pasting until you get the number of lines that you want? Probably not. Right? So what I'm going to do is I'm going to put in a loop of some sort. Now, which one would be more appropriate, a for loop or a while loop? A while loop. Why did we immediately jump to a while loop? Do you know how many lines are in that file? Not until you read them all, right? So while you still have a line to read the next line, read the next line, read the next line. Guess what? Scanner gives us an ability to do that. S.has next line, or has next integer, has next double, has next line is what I want because I want to read them line by line. While you still have a line to read, go ahead and read it. String line is equal to s.next line and print it out. Oops, system.out.println line. There we go. Once we're done reading that file, we need to make sure to clean up after ourselves and s.close. Right? There is a more modern way of doing this. It's a try with resources. If you want to, go ahead and read all about that, but I won't do that here. Right? I'm trying to keep things simple. Now let's run this. Hey, hello, how are you? A bunch of blank lines, some blank lines, a number 23. Now 23, is that an actual integer in my code here? Nope, it's still a string. Do we remember, if we expect an integer, do we remember how to convert it over to an integer? Integer dot parse int line. Now is that going to work for that first line? Nope. We're immediately going to fail there with an input. We failed trying to convert that number format exception. Hello is not a number. You can't convert that. I would have to wait until I get to the very last line to do something like this. But you can see what happens with an exception, right? That it's going to be fatal to my program here. We tried to read hello. We tried to convert it to an integer. That ain't going to work. Right? But this is how you read line by line by line. An alternative. Read the entire file into, what do I have here? A list of strings with a one-liner. Pretty much it's going to be a one-liner. Let's see, do I actually need, yeah, I do need an IO exception here. So I'm just going to go ahead and cut and paste this because I don't want to write it from scratch. There we go. Import files, import paths. Change this to bar because that's what I want to read. Output the contents. Read lines, data bar .txt. Bring this in as UTF-8 standard ... There we go. And oh, do I not need that? Oh, I need to import IO exception, apparently. I thought that that was part of the language, but apparently not. That's in the IO library. There we go. Once I've imported everything, hey, cool. There's a one-liner. If you want to read the entire file as just one big giant string, read string. Right? If you want to read the entire file line by line, but then you want it as a one-liner so that you can store that into a list of strings, right? You can do it in one-liner as well. And let me go ahead and run this and show you that it actually does work, right? So there's the first time that we do it, right? First time we do it is right here. Hello, how are you? And then here's the second time when we do it. Hello, how are you? One big giant string, right? All the way to the end to 23. And then here's the third time we do it as a list of strings. So however you want to do it, right? If you want to do it line by line because you need to process it. If you want to do it line by line, but you only want to do it in one-liner and then process the list of lines, right? Lots of different ways of doing it. Though that is all in the, not the input-output library, but the N input-output library. What does N stand for? I think it stands for non-blocking. So it's just another library that was added on later, right? Hey, this is such a common thing to do. Why don't we just give them a one-liner to do it, right? So there's file IO. Don't get more complicated than that, right? You might see some tutorials out there that ultimately tell you, oh, you need a buffered input writer. You need to wrap that in a non-buffered input writer. You need to wrap this class into that class into that class. And it just complicates stuff, right? Just go ahead and use what we've given you here. Those one-liners or a simple while loop, okay? Any questions so far? All right, so then let's go ahead and get rid of this stuff here and come back over here to this, right? And let me change my, actually, let me get rid of the file output as well. Let me change my bar file here to just be, say, 23 and then 42 and then, I don't know, hello, right? So over here in my demo, suppose that I do expect every single line in my file to be just a single integer. We'll go ahead and print out, instead of printing out the line, we'll go ahead and say add them all up, right? So let's go ahead and create a running total here. Int total is equal to 0. I'll initialize it at 0. Actually, let me not initialize it at 0. And what I'm going to do is I'm going to read that line in the file, convert it over to an integer so that I can sum up all the numbers in the file. Let me make it a clean file to begin with first here, right? So keep in mind, what is 23 plus 42 plus 101? I don't know. Let's find out, right? I'm going to go ahead and convert this to an integer, integer.parseInt, right, line. And then I'm going to add it to my running total. Total plus equals x. That should be okay in both languages, Python and C. Right? But it doesn't compile in Java. Why? Those coming from a C background, what do we emphasize when you declare variables? What do you have to do? Right, if this were C, what value would be stored in total right now? Who knows? Dead beef, 0, right? It's an uninitialized variable. In Python, if you just create a variable, right? In fact, the syntax doesn't even allow you to do that, right? Int x, that's not Python. The way of doing x in Python would be what? X. Does that have any effect? No. So usually what you do in Python is you immediately assign it a value. X is equal to 0. Right? In this case, Java is not even going to let me use it unless I explicitly do something like that. Now the compiler error is gone. When we're all done with this, let's go ahead and make sure to report our total, system.out.println total. So what is the sum total of all numbers in that bar file? Right? 166. Okay? Wonderful, that works. What's going to happen here? It's going to go to that first line, be successful. Second line, be successful. Third line, be successful. When it gets to that fourth line, what's going to happen? We have already observed that. It's going to throw an exception. What kind of exception was it? It was a number format exception, right? NFE. Right? And then I can decide what to do here. Right? System.error.println. A non-integer was found in the file, right? Go back to the drawing board. Go back to whatever you were doing. This is exception handling. You have a potentially dangerous piece of code, a piece of code that could potentially result in an error. You need a way of detecting that error and handling that error if you need to, right? In this case, you surround that code with a try block. Go ahead and try this potentially dangerous code. If something happens, right, and usually I use the metaphor of a cliff, right? If you're walking, what do you do? And there's a cliff. If you just keep walking, you're going to fall off. So in C, you have what's called defensive programming. You look before you leap, right? You're at the edge of the cliff, and you look over the cliff. Oops! If I take another step, right, I am going to fall off this cliff. So I don't do it, right? I turn around and go back the other way, right? That's an if statement. If I'm about to divide by 0, I don't do it. I turn around and go the other way. In Java, however, you have exception handling. You're about to walk off the edge of the cliff. Just go ahead and try it, right? Don't worry, because we will catch you, right, if you fall. And then we will put you back up on top of the cliff and let you decide what to do. Do you want to keep walking and cause the error again, or do you want to handle that error somehow? Right? Now, if you do know how you want to handle that error, right, that I'm about to divide by 0, so I'm not going to do it. I have a division by 0 error, and so I'll use a default value of 0, like 1 or something like that, or handle different math or something, right? Then you can go ahead and do that. But if you have no way of determining how you should proceed, for example, I want to add up all the numbers in this file. That file doesn't exist, right? How can you reasonably recover from that situation? Should I just make up my own file with a bunch of random numbers? Probably not. I want to let the program die at that point. So in that case, what I'm going to do is I'm going to throw a new runtime exception, and I'm going to wrap up E in it. Right? This is the file not found exception. That's what's known as a checked exception. We won't get into it too much here, but it was a mistake that was added in Java 2 or 3 or something like that. And objectively, we can call it a mistake because no other language has adopted this feature in the intervening 25 years. Right? One language has implemented this feature called a checked exception. It's called C++, but they decided after seeing the chaos and terribleness that occurred in Java because of this feature, they decided to make it optional. No other language that I know of has checked exceptions. What is a checked exception? A checked exception is something that you are forced to surround with a try-catch block and then deal with. As I said, how can you deal with a file not found exception? You're expecting that file to be there so that you can add up the numbers. How do you reasonably recover from that exception, that situation? You don't. You're supposed to let the program die at that point, right? So this is something that was added in Java by mistake. Ever since then, I've never seen anybody write a new library that has checked exceptions. But because Java bends over backwards to be backwards compatible, it is a feature that's not going anywhere. Right? It's a feature that's not going to be taken out at any time. It's a feature that we're forced to deal with. The way that we deal with it is simply by, okay, fine, generate that try-catch code, and then we catch and release. If anybody's ever been a fisherman before, I'm not a fisherman, but if you're fishing to eat the fish, then you keep the fish. But if the fish is, too small or too old or diseased or something, what do? You catch and you release. That's what we're going to do here. If you reasonably cannot find a file called Baz, we're not going to proceed. We're just going to let the program die here with a fatal exception. Right? That file not found exception got rerouted as a runtime exception, which is an unchecked exception, something that we're not forced to deal with. Just like this number format exception, it's an unchecked exception. We don't have to deal with it if we don't want to. Right? Let me change this back to bar. Now, that file will be found, but when we get to that last line, hello, then it's going to throw a number format exception that we're not explicitly dealing with here. Right? It's just going to be a fatal error. Right? Mostly you just want to catch and release like we've done here. Let me go ahead and restore that. There we go. Right? So the catch statements here are kind of like an if-else-if statement. The first one to get matched is the one that gets handled, right? So if it throws just a generic exception, and that exception happens to be a file of not found exception, then this will occur. If it throws a number format exception, then this will occur, right? And let me show you at least that part, right? All we're going to do is print out an error message here, and then move on with our lives, right? That's a nice way of doing it. That's another way of doing it, right? We're going to total up everything until we hit this exception, and then we're going to say, okay, a non-integer was found. You might want to deal with that at some point, but I'm going to, the program, I'm going to move on with my life, and I'm going to print out 166, the amount that I've totaled up to this point, right? That's basic exception handling, right? It is a headache to deal with for checked exceptions. The way that you deal with that headache is just by simply rethrowing it, catching and releasing it as a runtime exception. Right? And then you'll see the red stuff down here indicating that you need to fix something. Right? All right, so that's exception handling. Any questions so far? Okay. No? All right. Let's see, we only have 10 minutes left, so I don't know, what do we want to do? Do we want to do a very simple program? No, we don't have we could do a very simple program as an exercise to end the week. Yes, no, okay. This is usually done in the first couple of weeks of any CS1 course. Let's go ahead and convert, since it's cold outside, somebody look up the temperature in Fahrenheit, because of course most of us Americans will understand that it's going to be damn cold out there at like 10 degrees or something like that. But what is that in Celsius? So temperature converter, right? Let's go ahead and create a new program here. I'm going to create a main because I want this to be runnable. Public static void main string args, right? Except what did I forget to do? What's something that I should always start with? Documentation, author, date, and then purpose. This program converts Fahrenheit to Celsius. There we go. I spelled neither one of those correctly. All right, go ahead and look at your own spell checkers. I don't want to have to deal with that. Right? All right, so we need to read input. Do we want to read it in interactively, prompt them for input, and then read it in, or do we want to use command line arguments? Which one? Command line arguments? Okay. So first of all, I'm going to check to see, did they give me the correct number of command line arguments? If args.length is not equal to 1, I'm expecting one command line argument, Fahrenheit. What is the temperature outside right now? 16 degrees? I expect 16 degrees here. So if they didn't give it to me, I'm going to go ahead and go with system.error.println usage, provide a temperature in Fahrenheit. There we go. If you don't know how to spell something, you abbreviate it. And I'll exit on them because there's no way for me to recover from that. If you don't give me input, nope, that's it. That's the end of the story. Rerun me again at a later date with the correct way, right? Otherwise, if they gave me input, I'm going to go ahead and convert that. Should I convert that to an integer? You told me it was 17 degrees outside. Right? Is that the only degrees that you can have? 17 and a tenth, right? 17.4, right? So maybe we want to double instead. Right? And should I call this x? What is that a good variable name in general? No, not unless you're doing xy coordinates of something, right? You label variables what they are. And what is this in this case? F for Fahrenheit, avoid abbreviations. At this point, Fahrenheit, is that how you spell it? All right. Take a detour and do some spell checking. Oh, Fahrenheit. That's why we shouldn't use Fahrenheit, because nobody knows how to spell it. There we go. All right. Oh, is that a good variable name? That was just a cut and paste. Should variable names be upper camel cased? No, they should be lower camel cased. Now, how do I capture that input value? Double.parseDouble, right, of args of, where's the first command line argument? 0. There we go. Now, do I need to do any input validation? For example, negative Fahrenheit, 0 Fahrenheit, positive Fahrenheit. Those are all valid, right? So no input validation here needs to happen. What if they didn't do it correctly, and what if they mashed the keyboard and said hello instead? Keep that in mind. We'll figure that out here in a second. Otherwise, just go ahead and convert it. Celsius? Come on, help me out. That should be correct? All right, another spell check lookup. That's correct. Celsius. Okay, fine. All right, is he going to be equal to, how do I convert Fahrenheit to Celsius? Does anybody know off the top of their head? I think it's F2C formula. All I'm doing is looking it up on Google here, right? 5/9 or something like that, minus 32, or minus 32, something like that. We'll have to look that up. Minus 32 first? Okay, thank you. Now, before I move on, is this going to work? 5/9, what is that for those coming from a C background? Those are integers. An integer divided by an integer is an integer. So it's going to end up being 0, right? In Python, you could do this all day long. It's going to convert automatically for you. You can't do that in Java. At least one of those things needs to be a double. Or you could pull out your calculator and do 5 divided by 9 and then put that in there, okay? All right, system.out.println, and I'm just going to print out Celsius. You can make it as fancy and pretty as you want, right? I'm going to go ahead and run this, and we'll see that it's going to say, please provide a temperature in Fahrenheit. How do we do that? Run configurations, and you told me that it was 17 degrees today, or at least right now. It should be better on the weekend, and that's negative 7.777778 in Celsius. Before we go, right? One thing that you should have done by the end of this week is at least your test cases and an outline of your program. So there's been quite a few questions on what is a test case. Well, first of all, how do I know that that is correct? I see some people, how do they know that it was correct? You pulled out your phone or your TI-84 calculator, right? Before I ran this, what should I have done? I should have said, okay, well, today is 17 degrees. Go ahead and put that into a calculator, and I expect it to be negative 7.77 degrees. 17, negative 7.7, that's my test case. Input, expected output. Then I run my program on that input. Does that match my expected output? If so, it's correct, or at least I have some assurance that it's correct. That's what testing is all about. You've probably been doing this on every single program that you've at least run your program once, hopefully, right? And that's what you've been doing every single, minus 32. It shouldn't be that thing, right? We would have detected a bug right there, right? If we had done this correctly. Okay, it should actually be 8, or negative 8, right? That's what testing is all about. Let me go ahead and replace this, and here's how you don't test. You say, okay, well, it's 17 degrees outside. Run the program, negative 7. All right, that seems all right to me, right? It worked. Did it work? It worked, but was it correct? No. That's what testing is all about, and that's what you should be doing by the end of the week. Having at least 2 or 3 test cases built and ready to go so that when you actually write your program, you know that it works. You don't do it after the fact. You don't run your program and say, oh, that output, okay, that must be the correct thing, right? How do you know it's correct, right? You don't know unless you do your testing and test cases first. Okay? That's what a test case is. All right, have a good weekend.